Hi there. A random sample of people queuing for a train asked how long they have been waiting in the queue before buying their tickets. Their replies in minutes are 12, 17, 21, 9, 14, and 19. We need to calculate a 90% confidence interval for the mean stated waiting time. So the way we do this is, first of all, we're going to try and find the mean of x. So which is basically summation of x divided by n. The summation of x, if you were to add all of that from your calculator, you should be able to get 92, and then you divide by 1, 2, 3, 4, 5, 6. So 92 over 6, I'm going to get the mean, which is important for the calculation of the confidence interval. So this is 15.333 and so on. Recurring decimal there. Now, the next thing is we need to calculate the standard deviation. So how are we going to go about and calculate the standard deviation? The first thing I'm going to do is I'm going to calculate, sorry about the noise of the door there. Okay, I'm going to try and calculate the variance of x. And so how do we calculate the variance of x? Maybe sxx is going to be equal to the summation of x squared minus summation of x, all of that to the square over n. So summation of x squared, we're going to have to square each of these and then add them up, all right? And if you were to square each of these and add them up, you should be able to get 1,000. So basically, 1,512, if I'm not mistaken there, 1,512, that's very good. So then it's 1,512 minus the mean of x to the square, which is basically the 15 point, or maybe 92 over 6 to the square. So can I say 15.333 and so on to the square divided by n, and my value of n is 6. So if I were to do this on my calculator, so I'm going to get so this is basically summation of x to the square. Sorry about that. The summation of x here is basically 92. So that's 92 over, to the square over 6. And let me just do that. So we get something like 101.333 and so on. So this is my variance. And now if I were to calculate the standard deviation, basically, so the standard deviation is going to be, because that's a small size, so standard deviation of x is going to be equal to over n minus 1. So this is practically 101.333 and so on, divided by 5. And so let's do this on our calculator, and we look at that, we get 20.26 and so on. Let's say 20.267 to stop it there. And that's my standard deviation, so, or variance as such. Now, because we're looking for a 90% confidence interval, as I said before in my previous video, so 90%, let's say it's somewhere here. So basically, I'm going to do 1 minus 0.9 divided by 2, and all of that should give me 0.95. And my t value, why I'm using a t distribution value here, because the sample size is very small. You can see it's very small, it is 6 there. So the t value for 6, all right, so it's going to be, say, 6 minus 1 is 5, so 5, okay. And I'm going to look at this value in the t distribution table. So we're looking at 2.015. I'm sure you should be able to get this value from the table. Okay, so that's my t value. So basically now, if I were to calculate my confidence interval, so what do we do to calculate the confidence interval? So confidence interval, and I'm looking at a 90% confidence interval. So that's going to be the mean, which is basically 15.3, and so on, plus or minus my t-value, which is 2.015, okay, times the square root of the standard deviation, the variance, which is basically 20.267. I'm going to put 20.267, and all of that divided by the sample size. The sample size here is 6 of them. Okay, I'm just going to take away all that square. That was just for explanation purposes, but this is the question. And let me just do this calculation now. So what we're looking at is then 2.015 multiplied by the square root of 20.267 over 6, and we get 3.703. Plus or minus 3.7033. 44886, and so on. Now, if we were to calculate the upper limit, of course, I'm going to try and add this to 15.333 and so on. So plus 15 point, all that 3 is there. I'm going to get 19.0366, which is basically the upper limit. So that's 19. Let us say 19.04. And then I've got 15 point, all those 3's, minus 3.7033, 44, 88, and so on. That leaves me to 11.6. And 11.63, let's say, this is the lower limit and that's the upper limit. So here's my 90% confidence interval. Now, the second question, part B of the question, this A is done, and we need to make a comment. Comment on the company's claim that the mean waiting time is 10 minutes. Now, when we look at all the results we've got from those calculations there, we can see that 10 minutes is not in the confidence interval. So basically what I'm saying that this 10 minutes is even lower than the lower limit. So this confidence interval lies completely above the 10 minutes. So for part B, the confidence interval in fact lies completely above 10 minutes. So now the company's claim that the mean waiting time is 10 minutes is not true. So that can be rejected, all right? So the claim is then the claim that the mean waiting time of 10 minutes, the mean waiting time of 10 minutes, okay, by the company, this claim is made by the company, all right, is actually rejected. Not true, it's false basically. All right, so this is how we go about and calculate the 90% confidence interval for a small sample coming from a normal distribution, because the assumption is that all the data is coming from a normal distribution. And basically we've used the t-distribution again, okay? Why? Because our sample size is very small. I hope you've been able to understand this. Thank you for your attention.